Hello, hello, and welcome to Not Schedules a Stream and has no idea what to do. I came in here 100% unprepared with no idea what I want to stream, even though it has been over an entire day since I scheduled this stream. How irresponsible of me. Indeed. Today I feel like being a little irresponsible. Hi, I'm not this. So that does beg the question. What exactly shall we be doing? I don't know. Let's take a look. So, that's right. I do have this guy up as an option. We have Fantasy Star Portable 2 that also works. And then we have I'd rather save the card game for another day. Um, we have not game, which, oh, wow. Let's make a list to do and throw a dice. What I do when I have too much stuff to do. Oh, that's a good idea here. A very good idea. Which of these windows is it? Is it not you? Yeah, you. That's why were you black and white? I remember you being white and black. It I guess it doesn't really matter. Oh, that's the we'll be right back. And add some text. And I believe I have power clear. Power clear works. Okay. And let's get ourselves a nice clean black color. Here we are. That works. So we have not of this world. Not of this world. Not get it, this guy. Not as in not me. And not as in you guys. This guy uh is Fantasy Star Portable 2. Hmm. Oh, we do have Entry and Odyssey. That's right. Entry and oh man, it's been a while since I played that as well, huh? And then we have Nothing. We have Pokemon TCG. Rocket. And is that it? Is that all we have? No, there's gotta be more, right? Or are those the main things on the bucket list here? I mean, I can always do like art. What for? I have no clue. Uh, music. Compose. I'm new. I'm not. Did you ever finish your room? Oh, the room. I think we did. Didn't we? Let me actually pull that up here. Actually, no, I don't think we finished the room. It's like half complete. It's half complete, that's right. Old school RuneScape stream? Oh no. I think I've said this before, but I, I, I don't really want to stream MMOs. Oh no, 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 no. You do not need to see me getting salty at RNG. I mean, you already see me do that more than enough in single player games. Imagine the stuff that would I would be engaged in multiplayer, massive multiplayer online role playing games where upgrading your gear has, like a 50% chance to completely erase the weapon from existence. Imagine that. Like, no way to recover it unless you, I don't know, pay like 3 billion Zimbabwean dollars up front for the, protection potion. What's the game that has made you? Oh, right. Games, right? Games, platformer. It's about time we find another platformer game to play. Whatever. What's the game that has made you rage the most? We need to say that for Batsu streams. Batsu streams. Oh no. Oh no, it's all MMOs. It is all MMOs. So never. You can't have that for Batsus. Maybe you find like a really, the game that a kusoge that puts the kuso in kusoge, right? Find one of those for me to play. I'll gladly suffer through it. That will be both, I guess, a punishment, and I don't. Is it? I mean, if I enjoy it, does does it really count as that's, it's not for everyone. It's still suffering. We can take these. It's a win-win situation. We take those. Every drop is 50%. You either get the item or you don't. No, that's not how probability works. You dork. That is, okay. You know, let's have a math class. Today is going to be a math class. We'll teach you about binomial probability. So I think, yes, this is correct. Binomial probability. Okay, I may not be the best at math, but over the course of my suffering through MMORPGs, you either get the drop or you don't. Is I mean, it's an apt expression, but no, wait, sorry, that's not what I was. That's not the train of thought I was going for. Right. Over the course of playing, I'm. Let's go back to the beginning. Let's go back. Over the course. Yeah, wait, no. Even back further. Right. I may not be the best at math, but over the course of playing through many MMORPGs, binomial probability is something I have picked up. So, why is binomial probability so important? What? Why is binomial probability important? Actually, let's expand this text frame here. Let's expand it. This is going to be our whiteboard. Oh, it's kinda locked into proportions, isn't it? Sure is. Let's fix that. Well, don't, no, I don't really want to fix that. And then it won't look good. That's okay. We can use like half the board here. Oh no, now I'm covered. Where am I? Not, not Doko. Not, mm, ah, Doko da yo. Doko. Doko da yo. I cannot see. Okay. This gives us the entire whiteboard. What whiteboard? You know, I remember this being a blackboard, don't you? Whatever. Drop rates, good rates, and upgrade rates. Well, just rates in general. Rates, drops, upgrades, and more, right? Very important in your games. Very important, right? If you've ever played an MMORPG, right? There's always that rare drop that you really want. Boards, I had them all through school. Black, green, and white. Oh man, all of them. You really went through all the times. Anyway, where were we? Right, rates. So, drops, upgrades, and more. So when you go through an MMORPG, right, you'll notice, you know, there's like these rare items that you really want, and they I don't know. So sometimes you know, I guess when you play an MMORPG, it's usually okay. The gameplay loop is something like leveling up your character, right? That's one part, and then the other part is making your character stronger through other means, such as crafting equipment. Well, finding better equipment, whether that means like fighting bosses for them or crafting them, right? And among other forms of upgrades, like you might have a game exclusive mechanic where I don't know, it's tied into like some sort of lore that just gives your characters more abilities, right? And in terms of gathering equipment, itemization, that's that's a term that um let me look that up. I need to find a good itemization. Define. What do you say? Right. Itemization. No, that's not the right definition. Itemization. Itemization. Okay, so what is this? Okay, this is from the WoW Wiki archive. Itemization is not a clearly defined term in the MMORPG genre, but it generally refers to the balanced distribution of items, their types, and the various effects, powers, and statistics attached to them. So itemization is if your game supports like giving your characters equipment that strengthens them to let you do more fun things in the game to actually play the game, right? You're going to go through gathering, equipment. And equipment being, a very important part of these MMOs means that they should be rare, right? Good items are rare, right? You need to earn them somehow. You need to earn them somehow. So how how do we, what how do like wall or gate the player? How do we make the player work to earn these items? And like these powerful items are really good, right? How do we make the player work to earn these? Well, you can defeat bosses. Bosses will drop items, right? It's sort of like, you can gather materials or gather rare materials, no, just materials to craft items, right? Well, not items, just gather materials to craft, and I guess, okay. Those are the two main things. Those are the two main things. Okay. Where was I going with this? I was doing something with this. How do we make the player work to earn these items? Right, you can defeat bosses, and the bosses will drop these items, right? It's kind of like, beating them up and looting their corpse and going, oh wow, they had this really nice item. How did I even beat them in the first place? Oh, that's right. It's because I beat up a whole bunch of other bosses that had also pretty nice items, right? The cycle continues. It's a cool game. It's cool. It's a fun gameplay loop, yeah. You can gather materials to craft. That's also valid. And this is sort of an extension, right? Right. The thing basically glorified fetch quests. They're basically glorified fetch quests when you think about it, right? Oh, well, you have to go through this X, Y, and Z in order to, like finally get your reward. So, sure, you know, you beat this boss, and the boss will drop an item, right? Drop some good equipment. But if you beat the boss and the guy kind of just leaves you with everything, you have a problem. Your players won't play the game after that, right? Because, oh, it's a one and done deal. So, what do we do? Well, first of all, you can make the boss incredibly difficult to, actually defeat. And, well, then the game becomes sort of unfair, right? You can't exactly do that. I mean, you could. You could definitely do that. Right, you need to add replayability. And perhaps, maybe you want more of a, how do I say it? A rogue-like or a rogue-lite sort of gameplay loop. Or yes, if you do defeat the boss, you get everything. But if you die, you also lose everything. That's totally fine. But MMORPGs, for the most part, are not rogue-lite or rogue-like. They're undying, decaying corpses that have and are continuously reanimated through means through very unsavory means. through the means of monetization. Sorry. That's the word. Those are the words I was going to. And of course, that means, you really don't want your long term customers who pay for everything to lose it, right? It's like, oh, well, wow, $500 down the drain, and I don't even have a PNG to look at. It's just gone. No, you deleted it. Oh, man. Imagine how bad that would be. I hate microtransactions. Me too, man. Me too. Microtransactions. Okay. tangent. Back to the binomial probability in question. So where were we? Right. The reason why we have we have we have rates, right? So yes, replayability. Provide replayability. Provide replayability. Actually, that goes down here, right? That goes down here. Essentially, you want your players to keep on playing this game, and so it's like the easy way to do that is have them beat the boss multiple times. And you're like, okay, well, that's nice and all. Being able to, run through a raid or a dungeon or a field boss and kind of like gang up on it with everyone, or maybe even solo it. It's like, yeah, there's a little bit of skill challenge, maybe a thinking challenge involved. It's the player, playing your game, whatever that could be. And gets invested. They get to spend time on it. And it looks good on your game's statistics. Like, hey, look, our player base is actively engaging in the game. Well, the easiest way to do this, and the easiest way to do this, is by providing rates, right? Oh yes. Wait. Before we go to that, back up a little bit. Back up a little bit. And gathering materials to craft these items is sort of an extension of that. Instead of letting the player just simply grab the item, you introduce a second layer, another layer into the acquisition of good items, good gear. And you do that by giving the players more, more fetch quests. Like I don't know, 100 pieces of, or 100 shards of, this magical metal to craft your super sword, right? It's like, yeah. So, you beat up the boss, and it's a guaranteed drop for like one shard or something, and that's totally fine because it's guaranteed. So, yeah, I just have to beat this boss 100 times, and then I can get my weapon. What a great day! 100 weapons. I mean, no, 100 shards for one weapon. Kill the boss 100 times. That's not too bad. That's not too bad. Oh, I mean, okay, maybe that is a little bit bad, right? It's like, do you really want to do the same thing over and over again for like 100 times, right? I mean, it depends, right? How hard is the boss? If it takes you like a whole entire hour to clear the boss, well, no, I'm not spending 100 hours to get that really good item. No, 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 that's too much of an investment. I mean, other people might argue, you don't really have anything better to do, so I'm fine with that. And I guess, yeah, okay, maybe I might. If it's just 100 hours, maybe, No, but if it's like, okay, it's like a 10-minute run, sure, sure. I can do that. 10 runs a day, it's 100 minutes, just under 2 hours. Basically a side job. Something just good enough to go through on your free time. And maybe you make memories with, you know, random cues or whatnot, and you have fun, beating the boss. It's like, yeah, I'll take that. Whatever the case is, right? Oh, or maybe the other piece of the crafting is, that one like really rare item. You only need one copy of it, right? One piece of it, but it's a really rare drop. Like maybe I don't know, like a 2% drop rate for like your super magical shard, right? It's you can collect all these like you can collect 100 magical shards, right? It's like okay, sure, Now, all you're missing is the super magical shard to actually, like, complete the weapon. It's like a core component to craft it. Whatever that means. Whatever the game designers decide to put in, whatever nonsense. And, okay, this is, it's like 2%, right? What in the world? That's an expected, like, 50 clears for one? It's like, yeah, okay. You know, if I'm gonna grind like 100 shards, I'm effectively going to get an expected two, two super magical shards. Is what you might think, because that's what 2% says. And yes, that's true. That is the expected rate. And I'm jumping ahead a little bit now. Now I'm talking about rates and expected rates, which gives me, you know, good opportunity, which provides me a good transition into talking about rates. Rates. XCOM taught me to expect anything. Yes, yes. That 5% failure rate, that feels more like 20%. Not gonna lie. It's all, everything is a risk. It's all a risk. Do anything you can do to prevent that risk from happening. Do everything you can, anything you can. What was it? Anything wrong will go wrong. What was that called again? It was mass. Oh, it's Murphy's Law. Yes. Is it Murphy's Law? I think so. Anything wrong will go wrong. Yes. Expect anything. Expect the worst. Prepare for the worst and expect the worst. Rates, right. So rates, right? What are these rates? Right? Okay. So as I was talking about before, right? Okay, so yeah, maybe these items that you don't want the boss to drop every single time, or else it would be a one and done. So the easiest way to, prevent it being a one and done is giving it a percentage drop rate, or a rate, right? A probability. Provide a probability of the item appearing, right? Probability. And I jumped forward a little bit. I got ahead of myself again, and I talked about material gathering and how you have rates for that as well. The point is, all these items get a probability. It's a chance. I should say not probability. I should say chance. Provide a chance of the item appearing. So maybe the super good item has a 10% chance of appearing. So the devs expect you to maybe like beat up the boss 10 times for this thing and then call it good. It's like, oh, only 10 times? No, 10 times is actually quite a lot. I think so. That's a good amount of your free time invested into, playing the game. You're doing this thing 10 times. It's more than a good enough investment, I'd say. But you see, a 10% chance. Oh, hang on. Before I go into that, because that goes directly into binomial probability, right? And as as you if you play MMOs, as you've seen, right? They do this all the time, everywhere. You see it, drop rates for everything. You beat up a boss, items drop, percentage rates, everything. You craft an item, the materials have drop rates. You want to upgrade the item to make it even better. You have upgrade rates for that, right? Everything has a chance to it. And really, the chances, it's easy because it's a simplification of all the details, right? Okay, so instead of considering, the speed of airflow coming through your vent at midday, right? Oh, is it midday? No, sorry, it's not midday. It's actually evening at like Oh, you know, it's nearing sundown. So, you know, all these circumstances that are a little bit more uncontrollable, right? And maybe, you know, if you were playing some tabletop role playing game, yes, you could pick the right situations, right? And if you were playing maybe, well, if you were in the real world, yes, you would have to take into all of these considerations. And maybe there are some things that you forget to take into consideration. That those are therefore left up to chance. Maybe it's just the cosmic flux of the universe screwing you over like a bit flop. All of that, right? All of that. Also, lots of items that look cool but are actually useless. Yeah, that is also on the drop table because, well, you gotta put in fodder, right? It's like, okay, if there's only really like two or three good items in the boss and they all share like a 10% drop rate, well, you're not gonna see them often, right? So it's like, wow, this boss gives me nothing. That's not rewarding, right? I consumed all my resources for nothing. So, you gotta give the players some compensation, right? It's like a participation medal. Or yeah, compensation really. It just kind of pays your expenses that you went through, right? Other than time. You lose time. You're not getting that back ever. Another tangent. I forgot where I was already. Where was I? Where in the world was I? I was talking about upgrades and everything. Drop rates, percentages, chances, and how. Right. The cosmic flux of the universe. Cosmic flux of what did I say after that? Bit flops? Kind of like bit right. Right. Probability, right? So probability, all these chances, probability, all this probability is effectively simplification. Right. That's where I was going with this. So in a way, you know, if you're playing an MMORPG, you really don't have too much of a choice when you can choose the time of day because time goes on in the MMORPG world without you, etc. etc. And you have limited time and doing stuff, obligations in the real world, whatever. Right? So to make things easier on us all, we just add a little bit of probability just like that. And make it good. Make it simple. Clean and simple for everyone. The expense of this is that RNG rears its ugly head, and I'm about to show you why with binomial probability. Binomial probability. What is binomial probability, and why does that matter for all of these drop rates? Why does it matter? Well, binomial probability is. Oh man, how do I explain binomial probability? Right. Binomial probability is effectively. No, that's not what I want to say. Binomial probability is a term used to calculate. Probable. No, it's not a term used to calculate. It's a term given to probability that calculates what you can consider like a yes or a no. It's anything that has only two outcomes. Therefore, you have like the bi and binomial, right? Um. Oh man, it's been so long since I've binomial probability. So yes, in our case, it's a yes or no, right? A 1 or a 0, a true or a false, a heads or a tails, right? And sure, our most simple example of binomial probability is a coin flip. Heads or tails, right? An ideal coin flip has a 50% chance of heads, a 50% chance of tails, right? We do not consider the odds of it landing on the side. Does not exist in a theoretical situation. We have a 50-50. So, heads or tails, yes or no, right? Just two outcomes, hence binomial. And the way we calculate this probability is we say, okay, what are the odds? Well, we ask ourselves, like, okay, what are the? No, that's not what I want to. That's not what I want to go. Where do I want to go with this? Right. That does go back to average drop is 50%, right? You either get the item or you don't, right? You either flip heads or you get tails. It's a yes or a no. So in our case, it'll be 50% heads or 50% tails. 50%. We have right. We have a little equation that we use to calculate this, right? If we want to, find out, say, sorry, actually, yes. So what binomial, yes, this is where I was going. So what we do with what we use binomial probability for is to calculate the odds of, for MMORPGs, is to calculate the odds of getting a drop, right? Just like a coin flip, right? Heads or tails. This is the simple example. It's a 50-50, right? And you're like, okay, I want one head. I just need one head. I just need that one drop and I'm good to go, right? So you make that coin flip. It's like, oh no, it's a tails. Now I gotta do it again. So you ask yourself, how many times do I have to repeat this action? How many times do I have to beat this boss in order to get my drop? And so in our case with heads, it's not how many times do I have to beat this boss to get my drop, right? My bad. It's what are the odds, right? Well, we already know the odds, so we already know the odds. It's not what are the odds. It's how lucky or unlucky am I? Right? What is the expected total probability, like cumulative probability, that I will get at least one drop, right? The one item I need. And I guess the example here is like, say, I just need one head from a bunch of coin flips I'm doing. Say I do 10 coin flips, right? Actually, to make things simple, I'm just going to do 4 coin flips. I don't want to do 10. That's going to be a lot of typing. That's 5. This is 4. So each coin flip can be either heads or tails, and each has a 50% chance. Well, there's a 50% chance of heads, but we don't care about anything after that. I don't care if it's tails. So concerned about it being heads, right? It's either heads or it's not. Heads or not heads. So instead of calling this tails, we can call this heads or not heads. Not heads. Which means every coin flip has a 50% chance of being heads, right? So every coin flip, we do 50%, multiplied by 50%, multiplied by 50%, multiplied by 50%. That is our odds of getting 4 heads, right? It's like, okay, I need 1, right? So we can also get 50% times 50% times 50% times, well, whatever, right? We don't care. And that gives us 3 heads. We can also have, well, we get, 50%, that's 50%, and we don't care. And that's like 2 heads. We don't care about the other 2. Wait, no, that's wrong. That is totally wrong. Forget about what I just said, right? Forget about what I just said. My bad, my bad, my bad. That is not what I want to go through. Okay, so we have 4 coin flips. And so each of these coin flips has a 50% chance of being heads. But we only need 1 head, right? So your outcomes are therefore heads, 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 right? Heads, 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 tails. Heads, heads, tails, tails, heads, tails, 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 and tails, 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 tails. So you're looking at this and oh, that cuts off the whiteboard. I guess we can make it smaller. Yes. But what you're doing here, right, is we're looking at the, I believe, permutations. That's a math term. You don't really need to know what that means. But what we're looking at is the outcomes. Yeah, that's a better way of putting it, right? We're looking at the potential outcomes. And you'll notice since we only need 1 head, um, 4 out of, well, we have 3 outcomes. Out of the 4 outcomes, we have 3 outcomes, right? That give us 1 head, which means we have a 3 out of 4, or 3 and 4, right? And intuitively, you look at this and yes, that makes sense, right? But the math behind it gets a little bit more complicated when we look through, like, what if the drop rate was 10%, right? Suddenly it's not just a 3 out of 4. Well, our outcomes remain the same. Right? Let's say we flip the same 4 coins, but it's a 10% chance of heads. Well, now it's not actually 3 out of 4. Not 3 out of 4, right? Because when we're looking at heads, 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 these 4 heads, right? When we're looking at that now, we're looking at 10% times 10% times 10% times 10%, which is, well, since 10 is 1 to the 10 and we move that to the power of 4, we get 1 over 1,000, which is clearly not anything close to 3 out of 4. And you'll notice, like, okay, so, if this is 1 out of 1,000, this is 1 out of 100. No, this is 1 out of 2. Sorry, did I say 1,000? I meant 10,000. I can't, yeah. That's 4 zeros, right? And so this is 1 out of 100, and this is a 1 in 10, right? And this is, well, wait a minute. 1, 2, 3, 4. Oh my goodness. Did I? I'm sorry. I jumped the gun here. There's a tails. I can't count. Holy moly. Okay, it's fine. Please forgive me. Oh, I mean, three out of 4. Ah, no, that's so wrong. Hold on. let's go back in time a little bit more. Oh my goodness. Can you memory wipe yourself a little bit? Forget about like the past 10 minutes of me rambling. So we have our outcomes. We have our outcomes. We have all of this, right? And we're like, wow, okay, so we have five. We have five outcomes and four out of five. 4 out of 5 of them are well, 4 out of 5 of them contain heads. Oh, okay. 4 out of 5 of them contain heads, right? Intuitively, you look at that and you go, okay, yeah, think of that. That kind of makes sense. And now the math is a little bit off, but it's close. It's pretty close, right? If this is a 50-50. So what exactly is the math behind this then, right? That's what I'm here to explain. So we only need one head. And we're like, okay, so you want to 50%. To get 50%. Wait, so to get 4 heads, say, each head is 50%, you multiply that, 4 times itself. And since that's 1 over 2 to the 4, that is equivalent to 1 over 2, 4, 6, 8, 16, 64. Sorry, 16. 64 is 5. Yeah. And so, heads over heads, that's, 3 heads. That's then 1 over 8. And this is 1 over 4, and this is 1 over 2, right? And this is, well, tails, that's, well, we don't care about that. For now. But then you realize, right? Hang on. So I have four coins, and each of them can also be a different form of heads, and tails, right? They can be in any combination. So this heads, tails is the equivalent of heads, tails, heads. Because we don't care about the order in this case. All we care about is getting that one head. That one yes. So we're concerned about the combinations as well. And the combination math is like, that takes this into factorials, permutations, and I think it's the n and was it n choose n or n choose m or n choose p? I think that's how you write it, and like I don't know. I don't remember. But the case we consider all the combinations possible, right? And that actually outcomes in our case of heads, having 4 heads. I think that's a 4 choose 1, right? No, 4 choose 3. Because out of the 4 coin flips, we're choosing 3 heads. We're forcing 3 of them to be heads. And you do some funny combination math, and I'm pretty sure the outcome is 3. Because okay, now I remember. You have the math is n factorial. Oh right, it's CR, right? It's NCR, right? The formula is NCR here for combinations. It's NCR, and you're doing n factorial over, I believe it's r factorial. And I think that's it for combinations. It's that simple. No, I might be mistaking. Something. Let me double check here. So if we do 4 factorial over 3 factorial, that gives us just, I think it's just 4, which makes sense, right? Because the singular tails can move through each of these slots, each of these 4 slots. So there's 4 different orders of not 4 different combinations of that. Right. That makes sense. Yes. So there's 4, and so that's 1 over 8 times 4. And then 4 heads, heads, tails, tails, tails. We therefore have 4 choose 2. And if I do that correctly, that becomes 12 different combinations, right? That is... No, that is wrong. That is very wrong. Something is very wrong out here. I'm missing something crucial. We're missing something crucial to the equation here. Let me look that up real quick. Right, it is n minus r factorial. That's what we're missing. So in this case, n minus r, that's a 4 minus 3 is 1. 1 factorial is 1, which, makes sense. That's 4 total combinations. Yes, that makes sense. So this is over, let's see, 2. So what do we have? We have 4 factorial over, I believe it's 2 factorial over another 2 factorial. So that's That's 6, isn't it? Oh no, the math doesn't add up now because 1 over 4 times 6 is way over 1. What did they do wrong here? You know what? I'm gonna stop going off by memory. Let me do a little quick. Let me do a little quick search and I can explain it to you. Yeah, okay, I get it now. Okay, forget about all this math, right? Forget about it. Forget about it again. Let's do the time loop. We're time looping again. From the top here, right? So we have 50% heads, and we only need heads, and we see all of these, right? We see all of these combinations. We see all the potential outcomes of, having 1 head, and you have the outcome where you don't get anything, right? And what this does in turn is, well, you look at it and you're like, okay, right? Or what are the odds of this happening? And yes, you do have to account for the failures in this case, or else the math does not work, right? But just looking at the simple thing here is that you'll notice, what was it gonna make? Right. You have multiple combinations, so each combination, well, if you're looking at the probability of having, oh no, filler words are coming out. Oh no. The probability of 3 heads here, and you want to consider, right, 1 over 2, 3 to the power of 3, like 3 heads, right? And you want to also consider another 1 over 2 because that's the odds of you flipping tails as well. You want to consider that. Then you want to multiply everything by the total number of combinations that can happen. Now that makes the math check out for this. So 1 over 2 to the 2, which is 1 over 4, times 1 over 2 to the 2 times 1 over times 4, well, times 6. And so you actually have, this turns out to be 16 over 64. Nice. We're doing good. We're doing good here. And this turns out to be 1 over, sorry, not 1, 4 over, I believe it's also 16. And this is just simply 1 over 16. This is 1 over 2, right? 50%. But then you have 3 tails, so you need to consider that as well. Because nutheads also has its own probability you have to account for into this particular single combination, right? You have to keep that in mind. And there's also this combination of 4 choose 1, I believe, also turns out to be 4. So we get 4 out of 16. So tails doesn't really matter because we want the odds of 1 head appearing. So 0 heads appearing, of course, means this is 0. So we add all this up and you'll notice it turns out that we get a very generous 15 over 16 probability of getting 1 head out of a 50-50 coin flip 4 times. Now, I actually just introduced you to the equation of binomial probability, and that is your combinations where I think instead of R, we're going to put X as our variable, as in the number of outcomes we want, well, the number of yeses we're looking for, and we're looking at the probability of success, P, right, raised to the X power, meaning that that's only for 1 success, right, or 2 successes or 3 successes, just that specific number multiplied by the number by the probability of not P, right, failure, 1 minus P, also known as Q in some equations, raised to the I think it's n minus x, because that's the number of times remaining that you don't care about, right? So this is for only one specific number of drops x. Which is why if we want to find, all outcomes, well, we can have, if we want to find duplicates, then we have to go through, all of this extra math outcome to find those that also include more than 1 head, because they're valid, they're equally valid. You just got really lucky if you got more than, your 1 necessary drop. But you might notice that there's only 1 outcome in which you don't get anything. And that's what we're looking at. That's what we should be looking at. Because we can do the inverse of this equation. Well, the inverse of all of this, adding up all of this, right? We find the probability of this happening instead. So what are the odds of getting 4 tails? Well, there's only 1. one outcome, right, is 1 to the 1 half to the 4th, which is 1 over 16. So 1 over 16, that's your outcome for nothing, getting absolutely nothing. And what you do is you take that 100% odds minus 1 over 16. Like, subtract your odds of failure from your total odds, and you are left with your odds of success. And in our case, that gets 15 out of 16, which is the same as this 15 over 16 that we got. Yes, the math makes sense. Good. So, you say, what happens if we have, a 10%? What if the heads are now 10%? Oh no, you can't see the rest of this anymore. We're making this smaller as time goes by. What happens if, your heads is now 10%? Well, I'm going to actually clear the board here. We're going to wipe everything away. Leave our equation up there. And we're going to ask, so what if we have 10% drops? Well, 10% drops means 90% nothing, right? And to do this, we look. So to calculate, I believe, the odds of success, total success, out of doing, oh, what was it? Out of like, beating your boss like 10 times for this 10% drop, right? I mean, you look at 10%, right? Right, okay, actually, this goes back, I'm jumping ahead again. I need to make my thoughts a little clearer. Next time, I know this is the Zatsu stream, but next time remind me to, if I ever redo a binomial probability class, let me go over the material first. I honestly should have done that, because this is very, very much scuffed. Very much so. Anyway, right, so when you look at 10%, right, you're like, okay, well that means 10 expected bosses, right? No, not quite. Well, times yes. If we mean expected, yes. Not quite though. You can be a little bit unlucky, and binomial probably will show you why. Because say we beat the boss like 10 times, right? You expect a drop, but nothing happens. Why is that? Why? Why in the world? What happened? So because we have a 90% rate of nothing, and we're going through this 10 times, right? 90% to the power of 10, and I'll actually take this calculator here and push it through, is roughly equal to 35%. Okay, you can plug that in your calculator. So you have 35% odds of failure. So if you have 100% minus 35%, you get 65% success. Item dropped. So when you go through all this bossing, and you beat up 10 expected bosses, you loot them, and every time there's a 10% chance of getting a drop rate, you continuously stack those 10% over and over again. And you can get unlucky, because the math tells you, the binomial probability tells you that there's a 35% rate out of clearing 10 bosses, in our case here, you will get absolutely nothing of worth from it. You won't get that drop. It's 10%. But clearing 10 means that you have a 65% of success. It's silly. It's kind of silly, isn't it? It's like, huh? No. That doesn't. Does that make sense? Why does it work? No. That does that explain? Does that explain why I feel unlucky? Right? You know? Yes. It does. Well, okay. Maybe not all the time. Maybe you're just really unlucky when it comes to RNG. And you see here, the worse. I mean, sorry. The lower the drop rate, the worse it gets. Because so I have a 2% drop rate, right? That means I have a 50% expected. And you'll notice if I go and plug in 2% to the 50th power, sorry, that's not, if I plug in the inverse, the opposite, the odds of failure, which is 98%, I plug that in to 50 times, so 98% to the 50th power, will get us 0.36, which is 36%, with some spare change at the end, which leaves us with like roughly 64% yes, right? So you'll notice it's okay. That doesn't seem too bad, right? If I clear my expected odds, I'll usually approach this sort of like 60-ish% rate, right? Yes, you are correct. You'll see a pattern here if I go ahead and say, oh, what if I had 1% success rate? Well, then we have 99% to the 100. Because if I have 1%, then I'm expecting 99. And that gives us actually closer to 30. It's 36.6. It's like, 37%. So we get ourselves, 63%. So we're slowly, approaching 60, and by the time you hit 1%, it's like, oh no, it doesn't get any worse than that, does it? Well, maybe it does. What if we had like a 1 in 1,000 odds of something dropping, right? Well, then we have a 99.9, right? Or 99.9% to the 1,000. And we plug that in, and we get 36.7769. And yeah, it's basically 37%. And it'll feel like 63, right? It'll feel like 63. So, we roughly approach that like 63% deal. And just to be like a little bit more conservative when it comes to the math, we can just say 60, because I think it does go lower. But the case here is that the fun distribution, my beloved. Well, yes, but the case here is that how do I explain this? Okay, yes, the case is that you have basically 60% success rate if you clear the expected count. And so if you want to raise, you go and you look at 60%, and it's like, no. Those are those are horrible odds, right? It's like, what can you do to increase them, right? Because yes, you can get really lucky and you can get your drop rate on your first try. But if you really want a guaranteed drop, what does that look like? Well, with 100, well, with 1%, what happens if we do double our expected amount? Well, then we go 99% to the 200, right? Oh, that's 2 carats. And there we go. Okay, so that's 0.99 to the 200. And that gives us roughly 13%, which is roughly now 87. And it's like, wow, you know, that looks a lot better. But realize it took you double the effort and you still have over a 10% chance of getting absolutely nothing. So for 1 in 10 people who clear 100, well, no, for 1 in 10 people who clear 200 rounds of a 1% rate, 1 person, right? Sorry, wait, no, that doesn't make sense. So, no, out of 10 people, right? Out of 10 people who clear this 200%, I'm sorry, who kill us out of, no. No, I'm mixing the words. Okay, so, roll back, roll back some, right? Out of, out of 10 people, right? Who do 200 rounds of this 1%, 1 person will come out with nothing. Imagine that, right? If 100 people go through this, 10 people will get nothing. It is evil. Binomial probability displays this, and it's so important to actually like it's very important to know binomial probability for MMORPGs because this lets you calculate your actual luck. It's like, you know why do these games why are these games so bad, you know? Why does it seem like I'm getting nothing? Well, this is because this is what goes behind the math, right? This is the math that explains it. It's cool math. And this is why you see like 50%. 50% is super generous, right? Think about it. If you multiply 50% twice, you don't get 60 some. You get a whole 75. So higher rates, right? And because it's 50%, it's a lot more generous in that it's legitimately a yes or a no. Very equal, right? But once you start going lower and going beyond, 10% becomes 10% becomes just, oh man, at what 10% becomes really annoying at that point, right? Any at that point, yes, you approach that 65, right? And at that point, it feels bad. I guess that's what I'm trying to get at. It feels bad because you are forced to hammer through the grind, right? You keep on doing it, knowing that your odds of just getting a yes are really low. It feels bad. That's what Binomial probably tells you. That's how it works at the end, and this is like, oh man. Uh this is I feel like a broken clock now, right? Yeah, and that's just calculate that. No, sorry, that's just how you calculate your your suffering. That's how it works. Like, yeah, so for the next time you go into you go dying. Well, no, for that's why the next time you go into your MMORPG and you ask yourself, man, why is this item just never going to appear? Well, you know why. It's because the odds are probably low as really low, just horrendously low. And you're not gonna get it. You're never gonna get it. And if you didn't get it within like your expected odds, oh, well, good luck, because you're probably going to go through that a lot more, like double that, twice that. And if that doesn't happen, oh boy, it is it is so over. And see, this is also why I won't play old school RuneScape. This is also why I will not play old school RuneScape. Because I do not want to. I don't want to deal with your what is it? 1, 2, 3, 4, 5, 6, 7 odds. Maybe not the 7. What is this? What is this? This is a legitimate odd. This is a legitimate drop rate. This is a legitimate drop rate in old school RuneScape, guys. It's legitimate. I see this everywhere, okay? I see this. I see this. And I go, no. No, 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 no. You don't need to see me suffer through that. No. No, no, just no, 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 no. I rapid. It's a rapid fire barrage of no's. Just no. That is not happening. I refuse to participate in that. Uh, say no to gotcha kids. Yes, that is so true. Okay, for MMORPGs and gotchas, this binomial probably applies to gotchas as well. Why? Because it uses the same formula. Say you have a 0%, 0.05% of getting the SSR, that 5-star unit, right? Newest one on the banner, and you're like, oh boy, shiny PNG, oh boy, shiny PNG, shiny PNG, shiny PNG, oh, look at that art, oh, it's so good, oh my goodness, can you see the way the artist drew her thighs? Oh, oh my goodness, I need it, I need her, I need it so much. Okay, well, look at the math here, okay? 0.05% of success. So if we if we take the what are the expected odds, right? Well, if we take 1 divided by 0.0005, we get 2,000, right? So 2,000 tries expected. Holy moly, that is horrible, right? 2,000 expected tries to get your beloved PNG. Oh man, but I really want that JPEG. I really want that JPEG. No, it's not a JPEG. It's not just a JPEG. It's a live 2D. It has a live 2D, okay? You don't understand. This is next level technology. I need it. I need it. I need it. I need it. Well, whatever. You spend your money. I don't care. It's not my money. So what is that? It's like a 0.9995%, right? No, sorry, not 999 point. It's 99.95%. Yeah. So we have a 99.95% of just like actually getting absolutely nothing, right? Whatever trash units you're gonna draw, whatever gotcha toss that you right? It's useless. Recycle them, turn them into cores. You take that and you throw it to the power of 2,000. 2,000! Do you see how absurd that is? You need 2,000 tries just to get that. And yes, the math does check out. You do get that sweet spot of 0 point or 36.77 whatever, right, percent, right? Which, or it evens out to you just sucking up a 63% success. Like 2,000 tries. 2,000 tries. All for nothing. Look, that is horrible. And this is why we have a pity system, right? Oh wait. Actually, okay. You know what? This is why we have a pity system. This is also why we have rate ups, right? You know what a good rate up is? I know rate up is a lot, but allow me to explain, okay? Maybe on a very good day, you have those rates multiplied by 10. 10 times the rates. 10 times the rates. Now you have a 0.5% chance. Look. That reduces it all the way to 200. And I mean, it's still, your pesky 36, and it's still your 63% success. But you do get a 200%. 200%. Well, sorry, not 200%, but you do only need 200 tries. And, this 0.5% is actually, I think, pretty common in rate up banners for most gachas. So what you do here is, if you generously give them that 300 gold pity. Just because, you've got to double over, right, the expected. That's kind of how it works. Even though, if you do plug in like to the 300 power, it roughly approaches like 80%, 70-80%, right? So it's not like a complete guarantee, which is why pity does exist. And that is all for Binomial probability today. I know, like I've glossed through some things, right? Like, the more mathematical terms, like Poisson statistics, whatever the hell that means. Oh man. Ah, yeah. In our case, it really doesn't matter. What matters is that it feels like shit. It feels like shit. That's 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 the moral of the story. Drop rates are evil. They're horrible. If a game provides you with like anything under 50%, oh, it better be good. It better be good. Today I learned to keep Cheat Engine open. Oh, Cheat Engine. Yeah. Yeah. I mean, yeah, it's like, do I really want to farm monsters 10,000 times to get this rare item? No, I don't think so. No. No. I'll just. Maybe if you wanted to be, a little bit more generous to yourself, yeah, sure. Like after that 1,000th, well, 10,000th kill, like, okay, I didn't get anything, that's fine. I'll just cheat that item in. I worked for it. You can say I wasted my time now. Oh, Uh, yeah, that's that's it for today's math too, I guess. I think I want to make a proper not that I made this. I want to make a follow like a proper class. legitimate legitimate explanation because I do know that I flubbed a lot of stuff and I didn't gloss I well I sorry and I did gloss over a lot of the more formulaic stuff. More of the math terms as well. Too. I'd like to cover those properly so everything really does piece itself together instead of just, more lots of more rant about how bad things are and more math. Just more pure mathematics, right? Maybe. Oh man, but that mean I'd have to actually work and prepare? Oh no. Imagine doing that. Imagine preparing your stream. Could that be me? Yeah, I'll do a better job next time, chat. I believe. Why not? Have faith in me, please. It would be interesting. Yeah, it's also research for not game. That's true. Yeah, at the end of the day, you could say probability is sort of unavoidable in games. In one way or another, you will see it happen. Man, even card games too. Yeah, it's like, what are the odds of drawing a card? Well, it's not. Well, actually, yes, it is binomial probability. It's you draw the card or you don't draw the card. Well, it's a little bit more complex actually because you do have multiple copies. So it does apply binomial probability, but it's not simply binomial probability. Good stuff. And I think that will be all for today. What is the formula for the heart of the cards? No, that's called using cheat engine. You get cheats. Okay, the Ferris ability just lets him draw the card he needs. He actively cheats, like maybe unwillingly. I don't know, but it just happens. Okay, you don't beat that. it's just be lucky. That is so true. Just be lucky. More of the story. Next stream, not will teach us how to count cars at the casino. No, no, no. The house always wins. Don't bother. Don't. Uh. Well, yes. That will be all for today. And wherever you are, have a good rest of your day. Thank you for watching. Oh, not that